Today we are going to study about motion of charge in a uniform magnetic field. Suppose I have a magnetic field in the horizontal direction, that is I have a magnetic field in this direction and a point charge q is moving with a velocity v in the direction shown, making an angle theta with the field. That is, we have magnetic field in this direction and a point charge q is moving in this direction with a velocity v, making an angle theta with the field. So the magnetic force experienced by the charge, the magnetic force, the magnetic force experienced by the charge is given by F is equal to Q into V cross B. Here F is a vector quantity, Q is the charge, V is the velocity and B is the magnetic field, F is the force. So here V is the velocity, B is the magnetic field, theta is the angle between V and B. Theta is the angle between V and B. Theta is the angle between V and B. So we can write this as F is equal to Q V B sine theta. So this is the force experienced by a charged particle in an external magnetic field which is uniform. Here the magnetic field is uniform. So here it is a cross product of V and B. Therefore, force is perpendicular to both V and B. Note this point. Force is perpendicular to both V and B. So that's it. This is the force of a force experienced by a charged particle in an external magnetic field. So let's consider the case 1 or the first case where theta is equal to 0. That is, particle or the charge is moving along the direction of field. That is, the charged particle q is moving in this direction. That is, the angle made by charged particle with the magnetic field is 0. So theta is equal to 0. We can write F is equal to QVB sine theta and sine 0. Sine theta equal to sine 0, that is equal to 0. Therefore, the force is equal to 0. So the particle moving along the direction, the particle moving along the direction of magnetic field will not experience any force, will not experience any force. That is, the force on the charged particle moving along the direction of magnetic field will be 0. And the second case is case 2, theta is equal to 90 degree. That is, particle is moving perpendicular to the field. The charged particle q is moving perpendicular to the field. So we can write F is equal to QVB sine theta. Here sine theta is equal to sine 90, that is equal to 1. So we can write F is equal to QVB. So the force experienced by a charged particle moving perpendicular to the field will be QVB, where Q is the magnitude of the charge, V is the velocity of the charge, B is the magnetic field in that particular region. So, due to this force, due to this force, the charge will the charge will move in a circular path around B. That is, in the first case, the force is zero, but in second case, where the particle is moving perpendicular to the field, the force is QVB. Due to this force, the charge will move in a circular path around B. So, the charge will move in a circular path around B. Now, we need to find the radius of this circular path. How to find the radius? How to find the radius of circular path? So we know that due to the force QVB, the particle will move in a circular path, and now we are going to find the radius of that circular path. We have the force F is equal to QVB, and since it's a circular motion, this force is centripetal force, that is mv square by r. So we can equate this mv square by r is equal to qvb. So from this we can cancel one v. mv by r is equal to qb, and we are going to find the radius. R is equal to mv divided by qb. So this is the radius of circular path mv divided by qb, where m is the mass of the charge, v is the velocity of the charge, q is the charge of the or the magnitude of the charge, and b is the magnetic field. So we can say that if a particle is moving perpendicular to the direction of external field, then the particle will experience a force F is equal to QVB, and due to this force, the particle or the charge will move in a circular path of radius r is equal to mv divided by qb. So next we can find the time period of revolution. Next we can find the time period of revolution, of the charge. So we have speed is equal to distance by time, and time is equal to distance by speed. And for a circular path, the distance is the 2 pi r. The distance covered will be 2 pi r, which is the circumference of that circle, and the speed is v. So we have r as mv divided by qb. So we can write time is equal to 2 pi mv divided by qb divided by v. So we can write it as 2 pi m divided by qb. So the time period of revolution is given by t is equal to 2 pi m divided by qb. This is the time period of revolution of the charge, and we can find the frequency from this, which is nothing but the reciprocal of time period. Frequency of revolution is given by F is equal to QB divided by 2 pi m. Frequency is nothing but the reciprocal of time period. Frequency is given by QB divided by 2 pi m, and sometimes this frequency is called cyclotron frequency. So that's it. I'm going to summarize this thing. Suppose we have a magnetic field in this direction or the horizontal direction, and a charged particle Q is moving with a velocity v in this direction, making theta. The force will be F is equal to QVB sine theta, and the force will be perpendicular to both V and B. In case 1, if theta is equal to 0, that is the particle moving along the direction of magnetic field, the force will be 0. If the particle is moving perpendicular to the field, the force will be QVB, and due to this force, the charge will move in a circular path around B with a radius R is equal to mv divided by qb, with a time period of revolution 2 pi m by qb, or with a frequency of revolution qb divided by 2 pi m, which is also called cyclotron frequency.